Hello students. In the continuity of the last video about the distance traveled and displacement, I am here to add few more concepts about these two terms, distance traveled and displacement. At first today we will discuss about the concept of distance traveled and hence we will explain that what displacement is all about. So student, here, as I have told you and defined the term distance, that the distance is the actual length of the path, actual length of path covered by a body from initial point to final point. All right, initial point to final point. Let us understand this one. Okay, here student, suppose that a body is at A and this body covers a distance of 4 meter 4 meter towards the east direction, towards the east direction and reaching to point B. But this B is not final point. A is of course initial point, but B is not final point. Again, a body starts its journey towards the north and covers 3 meter of distance towards the north direction. So this is case number 1. In case number 2, okay, in case number 2, suppose that a body is again at A position and this body is traveling down in a direction of south and the distance covered is 4 meter. After covering the distance towards the south and reaching to the point B, a body is going to the west direction and reaching its final point, reaching its final point having distance of 3 meter. Okay, and case number 3, suppose that a body again starts its journey from initial point and covers a distance of 7 meter, covers a distance of 7 meter and reaching to the point D. Okay, here this direction is another. Here you can see that a body is going and traveling down a distance of 4 meter towards east direction, then moving to the north direction. What is the distance? What is the path length here? We will say path length is 4 meter plus 3 meter, that equal to 7 meter. In case number 2, okay, what is the path length? Path length is again A to B and B to C. So 4 meter plus 3 meter, that equal to 7 meter, right? Whereas when a body goes from A to D, okay, A to D, A to D, so path length is 7 meter. So is there any, what you can see here, is there any particular specified direction here? Because everywhere the path length is having its magnitude 7 meters, 7 meters, 7 meter, okay, irrespective of its directions. So Whenever direction is not counted, only magnitude is counted, such physical quantity is called scalar quantity. Scalar quantity. Hence, distance is a scalar quantity. Hence, distance is a scalar quantity. Alright. Now, let us understand about the displacement. Again, I am taking that a body is having initial point at A, traveling down a distance of 4 meter, reaching to point B, and finally reaching to the point C. A is initial point, A is initial point, C is final point, and 3 meter. This is towards the east direction, this is towards the north direction. So easily, as I have just discussed, that distance is 4 plus 3, path length is 4 plus 3, 4 meter plus 3 meter, 7 meter. Okay, but what will be the displacement between initial and final? We will say the shortest distance traveled. So A to C, this A to C is the shortest distance traveled between initial and final point. So students, displacement means shortest distance traveled by a body from initial point to final point. By using Pythagoras, we can conclude, suppose this is what? This is hypotenuse, this is perpendicular, this is base. So, by using Pythagoras, h square equal to p square plus b square. So, 4 square plus 3 square, this gives you 16 plus 9, 25. So h equal to root 25, that means 5 meter. So what is hypotenuse? Hypotenuse is AC. So AC is 5 meter. So AC is a displacement, okay, in the direction of north east, in the direction of north east. Okay, so displacement is equal to 5 meter in direction of AC. So here displacement needs a specified direction to be mentioned. Okay students, so this is the difference and it is known as a vector quantity. It is known as vector quantity. All right. Now we will discuss about the speed and velocity. Students, speed of a body is defined as the path length traveled in unit time. Okay, speed of a body. So speed, it is denoted by v. Okay, And mathematically we write, mathematically it is expressed as v equal to s by t, and its SI unit is meter per second or ms inverse. Okay, whereas velocity of a body is defined as the displacement. Displacement means path length in direction. Okay, defined as displacement traveled in unit time. So mathematically expressed, it is denoted, it is denoted by v vector. So v vector equal to s vector by t. So this is speed and velocity. Moving further, we will also talk about average speed, average speed is defined as, it is defined as the total distance traveled by a body in total time taken. Alright, now there are two possible cases. Case number one, when the distance is divided into two equal halves. When the distance is divided into two equal halves. And another case in average speed, when time is divided into two equal halves. So one by one. Okay, students, the topic is when the distance is divided into two equal halves. But before understanding this topic, okay, we will have to understand few concept about the initial speed and final speed, or initial velocity or final velocity. See, when a body comes from rest to motion, rest to motion. So initially, do you contain any speed within you? We will say no. So that initial speed, when you are resting, you are having no movement in the body. So that speed is called u. It means initial speed. So whenever a body comes from rest to motion, initial speed is 0 meter per second. Okay, so this is number one. And number two, when a body, okay, comes from motion to rest. Suppose you are driving a bike, you are already in motion, but all sudden, all sudden, you find there is a jam in a road and you are compelled to apply the brake. All right. In that case, initial speed, initial speed, again it will be denoted by u but will contain some velocity. So it is v meter per second. Okay. But here, on applying the brake, final speed, which is denoted by v, will comes down to the magnitude of 0. Alright, where when a body comes from rest to motion, initial speed is 0, but final speed will contain some speed, so it is v meter per second. Alright, so this is very important concept to go further in this chapter. So our topic was when the distance is divided into two equal halves. Student, let us consider a body's position A here, and this position is B. This A position is initial position and B position is final position. Alright, so we have considered the distance between the two is x meter. Distance between A and B is x meter. Our topic is distance is divided into two equal halves. Okay, suppose this x meter numerically we are considering it as 30 meter. Okay, so 30 by 2 it is half, that means 15. So 15 meters, suppose this point is C and this is 15-meter scale. Okay, now what is the distance here? If x is the total distance between A and B, A to C distance will be x by 2, correct? And C to B will be again x by 2 distance meter. Alright, so distance between A and C is x by 2 meter. So distance again between C and B is equal to x by 2 meter, because the distance is divided into two equal halves as the case is mentioned. So let us consider a body is having one speed between A and C, and this speed, suppose that speed is A, and between C to B, A meter per second, I am naming it here A to C. It means this is V1 and the V1 is the velocity speed between A and C, and I am considering it as A meter per second. So V2, the another speed between C and B as a B meter per second. Alright students, so student, here We have studied about the average speed is denoted in such a way. So average speed is what? Total distance by total time taken. So total distance means what? S1 plus S2 by T1 plus T2. Now, what is S1? S1 is the distance between A and C, which was x by 2, plus S2 is distance between C and B, which is x by 2. Now what we have to find? T1 plus T2. So students, T1, so time equal to what? Distance by speed. Time equal to distance by speed. So distance is x by 2. It is a distance by speed. What is speed? T1 means what? The time taken by a body for covering the distance between A and C. A and C. So time equal to distance by speed. Speed is A. So this becomes x by 2a. Similarly, the distance between C and B and the time taken for covering this much of distance will be again time equal to distance by speed. What is the distance? Distance is half of the distance x, that means x by 2. And what is the speed? B. So we will say x by 2b. So now this is T1, this is T2. So in place of T1 we can put over here x by 2a plus T2, that means x by 2b. Okay. Further we will solve. Now I am solving here. So VAB equal to x by 2 plus x by 2, that means x. Here the LCM will be 2AB, so it will be 2a cancel, so it will be bx plus ax. Now student, x by okay bx plus ax into 2ab. X can be taken as a common, so a plus b into 2ab. X got cancelled, so average speed VAB equal to formula that we derived 2AB by a plus b. So this is the formula for average speed when the distance is divided into two equal halves. Now there was another case number 2. Case number 2, when time taken by a body is divided into equal halves. Alright, into two equal halves. Again the same case, A, this is B, this is C. Okay, suppose time taken from A to B is 1 hour, so half time will be 30 minutes. Okay, so here time T1 for AC is equal to what? T by f2, and for time t2 cb for t by 2 again, because time is divided into two equal parts. Now what will be the s1 distance? So distance AC will be distance equal to what? Speed into time. So what is the speed I have considered in earlier case? A meter per second between A to C and C to B meter per second. So S1 equal to, it means distance equal to speed into time. So speed is A and time is T by 2. Similarly, S2, that means the distance between CB will be equal to speed into time again. So B into T by 2. Alright. So average speed equal to again what? S1 plus S2 by T1 plus T2, right? So what is S1? We will say S1 is A T by 2 plus B T by 2 divided by T1 plus T2. So T1 plus T2 means what? T by 2 plus T by 2. T by 2 plus T by 2. So here T by 2 can be taken as common, and A plus B will remain inside the bracket. So T by 2 plus T by 2, this will give you T on adding. Now VAB, that means average speed, T into A plus B, this 2 will come lower down into 2T. So TT got cancelled. So A plus B by 2. So average speed will be A plus B by 2. A is what? Speed. B is what? Speed. So summation of 2, 3, okay, it is actually a mean of speed in this case. So this is the average speed when the time taken by a body is divided into two equal halves. Thank you very much.